Good morning, everyone. Happy Friday. Today we're going to be discussing lesson 37. We're going to be talking a little bit about chemical compounds as well as parallelograms. So we're going to get two different topics in this lesson. We'll go ahead and start with chemical compounds. I'm going to go down here and get a blank sheet of paper because I want to just introduce a few things to you before we actually move on. So let me get myself some paper. Here we go. Okay, I want to discuss just a few things with you. I'm not sure how many of you have had chemistry, if any of you. Maybe some of you are doing it this year. I'm not sure, but some of these are pretty standard things that we know. For example, we know that H2O is a water molecule that is made up of two parts of hydrogen, which actually the hydrogen is considered an atom and part of the molecule, but we have two parts of hydrogen and one part of oxygen, and that is a water molecule. Something else that we want to know is that every atom that's made that makes up the water molecule, or any compound, has its own weight, and the weight of these atoms is actually called a gram atomic weight. So that seems pretty fitting. So they're measured in grams, and because they're atoms, they call it atomic. So it's gram atomic weight. So the way that this works is, I'm trying to look here in my notes. Okay, we've got one oxygen atom, here we go, one oxygen atom weighs, this is as a matter of fact, weighs 1 gram, or 16 grams, okay? And in this water molecule, we have one oxygen atom. So the oxygen's weight is 16 grams. The hydrogen weighs 1 gram, but there are two in the water molecule. So the grams are 2 grams in a H2O molecule. We add those together to get the total weight of this molecule, which is 18 grams. Okay, that's how that works. So we're going to move into our first example. Let's say we have, actually, you know what? Before we do move into that, I'm going to use this information. I'm actually going to just do one for you to watch for a moment. So let's say we have 3,600 grams of water, which we know, of course, is H2O. And let's say we want to find out what the weight of one part of this molecule is. So what is the weight of, let's say we want to find out oxygen. All right. So the first thing that we want to do is let's figure out the molecular weight, which we actually have already figured out above. We've already talked about the H2O molecule. We said that, and I'll just redo it here because I want us to get in the practice of this. We said that one oxygen atom is 16 grams, and there's one in this molecule, so that's 16 grams. And then we said that the hydrogen weighs 1 gram, and there are two in it. And so that is 2 grams total. So the total of this, we figured this out up top there just a moment ago, but the total weight of the H2 molecule is 18 grams. Now, there are 3 possible ratios that we can make up to help us solve this problem. And maybe you're already thinking about what they could be. The first one could involve, and I'm going to look right up here where I have my molecular weights, okay, right here. I could set a ratio that's going to have oxygen. Actually, let me start with hydrogen. Well, I guess it doesn't really matter, but okay, we could have oxygen over hydrogen. Trying to see why we have, I guess it doesn't really matter. You know what, I'm going to turn it around only because I think I wrote this out of order. I should have put hydrogen first. It doesn't really matter, but I'm going to try to stick with what the book was saying. So I could have hydrogen over oxygen, and I'm going to just put that as oxy so we don't get that confused with the 0. And if I did that, I would write the ratio as 2/16, or I could use hydrogen over the total, which would just be T, which would be 2/18, or I could use oxygen over the total, which would be 16/18. So we have to ask ourselves which one of these is most fitting. Well, let's determine what we have. What are we looking for? We're looking to figure out the weight of oxygen. So it's probably going to be either this one or this one. How do I know which one? Well, what other piece of information do I know from this problem? I know that we're looking at 3,600 grams of water. So I have a total amount given to me of water that I'm trying to make an evaluation on. So I'm going to want the one that involves the total. So this one right here is going to be the ratio that we're going to use. Not this one over here. Okay, so let's set up our ratio according to the information that we have. So I'm going to write my oxygen over my total, which is going to be 16/18, and I'm going to make this a proportion to what I'm trying to solve for, which is the oxygen, and my total was the 3,600. So here's my proportion. So if I could do cross products here, I would have 18, and I'm going to put oxy so we don't get confused about that O being a 0, equals 16 times 3,600. When you do the math on that, you get a pretty big number. It's 57,600. We're going to divide both sides by 18, and if you put this in your calculator, you're going to find out, I'm starting to write my last name. Oh dear. So the oxygen part of this molecule weighs 3,200 grams. Okay, so that's how we would figure that out. Now we're going to do a couple of these problems, and we're going to go ahead now in your packet or in your lesson there that you hopefully pulled down and printed and are ready to go with. We're going to look at our first example, which involves ammonia. I'm looking here. Okay, great. Awesome. Alrighty, so we have a chemical formula for the molecule ammonia, which is written as NH3, which means you have hydrogen, 3 parts hydrogen and 1 part nitrogen that makes up this molecule. And we are going to notice here that the hydrogen right here, hydrogen has a gram atomic weight of 1. And this is how you would see it in a problem. Actually, it's going to look like this. When you read these problems in your book, it's going to show you at the end of the problem, it's going to give you the atomic weight for each one of the parts of your molecule. And then we have nitrogen has a gram atomic weight of 14. Okay, so we know then that the nitrogen is 14. So let's figure out here, we're going to write in our molecular weights, and I'm going to write right here. You might want to go ahead and add this into your notes. These are the molecular weights. So let's figure out the nitrogen. So there's 1 part nitrogen, right? So I'm looking at this here. There's 1 part nitrogen, and we're going to multiply that with its weight. We're told that, oops, I'm looking at the wrong thing here, 14. Nitrogen is, yes, okay, sorry. Yes, there's 1 part nitrogen, and it has an atomic weight of 14. So its total grams, the total weight is 14. The hydrogen, we have 3 parts of hydrogen, and its weight, we're told, is 1 gram. And so that, in that molecule, weighs 3 grams. So the total here is going to be 14 plus the 3. So you're going to get 17 grams. And that is the weight of that whole molecule of ammonia. Now we have 3 ratios that we can consider that we're going to use, that we're going to choose one that we can use to actually solve this problem. The first one could be nitrogen over hydrogen, which would be 14 over 3. Or we might use nitrogen over the total, which then would be 14 over 17. Or we could use hydrogen over the total, and that would be 3 over 17. So let's consider what we have. We know that we have a total amount of 510 grams of ammonia, so we're looking for one with the total. So it's going to be either B or it's going to be C. Well, how do I determine? Well, what am I looking for? I'm looking for how much the nitrogen weighs. So I'm going to want the one that has nitrogen and the total, the one that's 14 over 7. So let's set up our proportion here to solve this. So I have, I'm going to go ahead and start with, I'm not going to rewrite this. I'll just leave it right there. And we're going to go ahead and fill in what we have. So I have nitrogen over my total, which we can go back to the problem and see what was the total, 510 grams, equals 14 over 17. We can do cross products here. I'd have 17N equals 14 times 510. When you do the math on that, you're going to get 7,140. You'll divide by 17 on both sides, and N is going to equal 420 grams. If you put that in your calculator, you should get the same. And that's how much the nitrogen in that molecule weighs. Okay, so you can use various parts of your information to set up a proportion and solve for whatever it is asking for. So let's do one more like this. We have a chemical formula for ammonium chloride, and that is written as NH4Cl. The N is your nitrogen, the H is your hydrogen, and there are 4 parts of that, and then there is 1 part of chlorine. Now we do notice here we're given our atomic weights for this, and excuse me. Excuse me. Okay, so we have our atomic weights here. We know that nitrogen weighs 14 grams. The hydrogen weighs 1 gram each, and we have 4 of those in this molecule. And then the chlorine weighs 35 in this molecule. Okay, so we have how many grams of chlorine are there in 1,060 grams of ammonium chloride? So let's first find the molecular weights for each one of those parts. So we have our nitrogen, which we know there's 1 part of nitrogen that weighs 14 grams. Our hydrogen, we have 4 parts hydrogen that weighs 1. I'm going to get that from right up here, grams. So that's 4 grams. The hydrogen doesn't weigh very much, it looks like. The chlorine, we have a weight, we have 1. And we're going to multiply that with its weight of 35. And that's 35 grams. And then, of course, our total, when you add those three together, you're going to get 53. And that is the weight of the entire molecule. I need to just fix something in my notes really quickly here. Okay. Alrighty, so let's see, how do we want to figure this out? So we're looking for how many grams of chlorine, and again, now we have a total. So I'm not even going to write out our three choices because we've done that already a couple of times, so perhaps we can already see what we need to do. Let's set up our ratio to start with our chlorine over our total, since that's what we're trying to find. We're trying to find the chlorine and we have the totals information. So now let's set this up. We're going to have our chlorine, which we're going to get from right here, is 35. Our total is 53, and let's set this up to a proportion. The chlorine is what we're trying to find, so we'll keep that one as our variable. And our total is 1,060. We use our cross products here. We're going to get 53 Cl equals 35 times 1060. If you put that in your calculator, you should get a pretty big number, 37,100. We'll divide both sides by 53 and work this through to the end. Put that in your calculator and you should come up with 700 grams is the weight of the chlorine. Okay, so it's not so bad. I got a little bit nervous when I saw all the chemistry coming up, but as I worked through it, I saw it wasn't so hard to understand once you've worked through a couple of those. Okay, so you're going to see one of those in your practice set, I think. No, I think it's going to be in the lesson problems. I only gave you one practice problem. Okay, so let's move on to parallelograms. Okay, parallelograms have four special properties, and they are that all pairs of parallel sides are congruent, opposite angles are congruent, the sum of any two adjacent angles is 180 degrees. Remember, adjacent angles are angles that are side by side. So like this angle and this angle are adjacent. Also, this angle and this angle are adjacent. So those that are beside each other are considered adjacent. If they're across from each other, we refer to those as opposite angles, which we refer to in number 2 of the special properties. And then lastly, the diagonals bisect each other, which means then that it's going to create equal, if you have diagonals in here, it's going to create equal line segments. Okay, and actually we're not going to spend a lot of time on that in this lesson. We're just going to know it to be true. But in lesson 39, we'll spend a little more time on number 4. So we'll just put a little note there for that. All right, so let's talk about what a parallelogram is. Parallelogram is a quadrilateral, which means it's a 4-sided shape with 2 pairs of parallel sides. So what I'd like you to do is go ahead and mark these up as though they have parallel sides. So we'll put 2 little arrows here, meaning they're traveling in the same direction, and put one on the other sides. We're also going to name this A, B, C, D. And we're going to go through a series of things here just to prove some things to be true. Okay, now let's think about something. We have parallel lines, and you guys probably have already covered somewhere what a transversal does when you have parallel lines. So I want you to draw your diagonal. Oops. From D to B, just put a diagonal line in there. Doesn't have to be perfect, like mine was not. Try to make it a little bit better there. There we go. Okay, put a diagonal in there. And then I want to make some determinations. Remember, this diagonal is your transversal. So when you have parallel lines with a transversal cutting through, it creates special relationships between your angles. So if I look at this angle here and this angle here, hopefully you can say, ooh, I know those are going to be congruent angles because they're alternate interior angles. So I'm going to put just an extra line here to show that those go together as congruent angles. And then, of course, here are also alternate interior angles, and those are congruent. I also want you to number these 1, 2, and 1 and 2 so that you can see who goes with who. Okay, now let's talk through a couple other things. We also know that this diagonal that we drew in here into this parallelogram shows that we have a side that is equal to itself. So if I look at this thing as though that diagonal created two triangles, I have this triangle that has 180-degree angles in it. I have this triangle that has 180-degree angles in it, right? But I've got two triangles, so that diagonal is a shared line. So it's congruent to itself when you're thinking about the relationship between those two triangles that we've created. Another thing that you probably can see is that if angles 1, the corresponding angles 1 in both of those triangles and the corresponding angle 2 are corresponding and congruent, then angle A has to be congruent to angle C, right? Because if these two are congruent to each other, if 1 and 1 are congruent to each other and 2 and 2 are congruent to each other, then that third angle has to be congruent to the other third angle, the other corresponding angle in the triangle. Okay? So what I see here is that because of angle, 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 that would mean I have similar triangles. If I add the side in there, because now if the side is the same length, then that means all the sides, the corresponding sides are all going to be the same length. So that angle, angle, angle side is what says that triangle ADB is congruent to triangle CBD. Okay? And since those triangles are congruent to each other, all sides are going to have matching, opposite sides are going to be congruent. Corresponding parts are all going to be congruent. So I could mark up this side. I could say BC is now congruent to AD. That's its corresponding side. And then also DC is congruent to AB. Okay, so we definitely have two congruent triangles here. And we note, just as we said in number 1, pairs of parallel sides are congruent. Opposite angles are congruent. So let's prove here that the sum of two adjacent angles is 180. All right, so I'm going to draw this little, I'm just going to go up here and draw this little by hand. I'm going to draw this little parallelogram. And I'm going to say, all right, I've already proven to myself and to you that our opposite angles are congruent. So I'm going to call my opposite angles, by the same variable's name. So I have x's and y's that are sitting opposite each other, showing that they're congruent to each other. Okay, I'm going to make this little... Okay, well, first of all, let's go back. Another thing that we were able to see is that if I have two triangles inside that parallelogram and the measures of the angles is 180 in one triangle and 180 in the other, then we know that the total of all the angles is 360 degrees, right? So I could set up this little equation here. That's 2x plus 2y equals 360 degrees. I could divide everything by 2. I'm sorry, guys. It's late at night. Okay, and I'm going to end up with x plus y equals 180 degrees. So look at that. What is the relationship of x and y? They're adjacent. So there's how we can prove that adjacent angles will total 180 degrees. Okay, so they're supplementary. Sum of the two adjacent angles in a parallelogram will be 180 degrees. Okay, so looking at that, we just proved a whole bunch of stuff. Now let's look at this last example here. We have parallelogram ABCD, and I'm going to have you fill in some parts here. We're going to label this A, B, C, and D. Okay, and this is actually, I think I pulled this right out of your book, but just follow me here. We're going to fill this in. This little line segment is y plus 7 is its measurement, and this side is 4. This side is 7, and this side is x plus 2. I also know that, let's look at the instructions tell us here. So try a parallelogram ABCD, and the measure of angle BAD, so let's find that right here. Angle BAD is 65 degrees. We need to find the measure of ADC, so what we're trying to find here, I'll use a different color for that. We're trying to find the measure of this, and DCB, this. Okay? So let's use what we have. Let's take our first step over here. Let me make this a little smaller so you can still see it. Okay, so number 1, I'm going to circle here. Let's find the measure of angle ADC. That's the first thing listed over here, so let's go for that one. All right, so ADC is right here. How can I figure that out? Well, remember, adjacent angles total 180 degrees. So if I know one is 65, if I subtract the other, that should give me the missing angle. So remember, just make a little note here. The sum of adjacent angles is 180 degrees. Let's look for the second one. The measure of DCB and that is going to be this one right here. So that's an opposite angle to angle A, and angle A over here is 65 degrees. So if angle A is 65 degrees, well then so is angle C. So that one's 65 degrees because opposite angles are congruent. I'm going to use a little symbol for congruent. Number 3, they also want us to solve x and y. So it doesn't matter which one we do first. I'll go ahead and just do y plus 7 one. Okay, so we were told up here, we didn't really get involved in it. We're going to see it more in lesson 39, but up here, the fourth special property regarding our parallelograms tells us that diagonals bisect each other. Well, if it's bisecting, we know it's cutting it right in the middle. So that means y plus 7 has to equal 4. And then for the last one, here's what we're going to solve. X plus 2 is equal to 7. So just so you know where I'm getting that. Y plus 7 equals 4. So let's solve that. We're going to get -3. And for the last one, we're going to get 5. X is equal to 5. So there's 4 things we were able to come up with on that parallelogram. So remember, the angles of a parallelogram, the sum of those angles is 360 degrees. Opposite angles are always congruent. Opposite sides are always congruent. It's a quadrilateral that has 2 pairs of parallel lines. So there's a lot of things to remember about it, but as you begin to work with this more and more, all those rules will become solid. I'm not going to do letter C with you because I've already been on with you for almost a whole 30 minutes. So I'm going to cut off here in the next 10 seconds and let you go ahead and work on these. If you have any questions and you want to try to reach out to me during the day, feel free to do that. I'll do the best I can to try to get back with you at least at some point. I will do my best. Otherwise, bring these to class on Tuesday with questions that you may have, but please give it an honest shot. Try to do what you can do, and I hope you guys have a wonderful weekend. Thanks so much for watching. Bye-bye.